Welcome to Spring LIB.
This is the answer to Chapter 31, problem number 22 from the Smith Organic Chemistry textbook. And this problem asks why chemical recycling with high density, sorry. So this problem asks why is chemical recycling difficult or essentially impossible with high density polyethylene and low density polyethylene, but possible with other polymers. And so the answer is found in the structure of these molecules. So HDPE and LDPE both are polymers of this form from this monomer, whereas I've chosen PET, which is I've chosen PET, which is polyethylene terephthalate, for the purposes of comparison. So actually, yeah. So I'm going to label them. So PET, polyethylene terephthalate, at the bottom, and we'll just say high density or low density, right? Because they're both formed from this monomer, and so basically, what we're talking about with chemical recycling is using chemistry to reduce these polymers back to their monomers, and then reuse the monomers in a whole new polymerization. And so with, for example, PET, this is possible to do. So the textbook tells us that if we heat PET in methanol with some acid, and we'll just throw some heat in there. So what actually happens is we break this polymer down, and we end up getting ethylene glycol. And dimethyl terephthalate back. So, right. So when we heat PET with acid in methanol, we get our two monomers back. Versus when we look at HDPE or LDPE, there's no good chemistry to break these carbon-carbon bonds, because the only types of bonds in HDPE and LDPE are carbon-carbon and carbon-hydrogen. So these ester linkages in the PET give us a handle or a point to attack with hydrolytic chemistry. There's no way to hydrolyze a carbon-carbon bond. Carbon-carbon bonds obviously can be broken, but it requires a great deal of energy and harsh chemicals, and so there's no good way to do this with HDPE or LDPE. So just for visual representation, I'll just draw that. Right, so there's no existing chemistry to easily reconvert HDPE or LDPE to its monomers, whereas with other types of plastics that are joined by carbonyl-based linkages, so esters, amides, things like that, we have handles to attack with chemistry to break these polymers back down into their monomers. And so that is the answer to Chapter 31, problem number 22.